Introducing the Spatial Workshop. This browser-based application is where the services you see in the Geoprocessing panel in MapX come to life. By combining geospatial Lego pieces or operators into logical models, you can build just about any of the manual repetitive tasks analysts perform on a daily basis. The hundreds of operators comprise decades of industry-leading geospatial IP in remote sensing, photogrammetry, radargrammetry, and GIS. Users string these operators together into models that can perform data preparation tasks like simple RSet generation, used to improve display performance, atmospheric correction, to remove haze and make the image clearer, complex 3D orthorectification, which ensures the subsequent measurements and analyses are accurate, and land cover classification, which is typically used as an input in other models. In addition, models can perform analysis using multiple data sources and user-provided input variables. Examples include change detection and mounted and dismounted cross-country mobility. Let's take a closer look at one of the sample models. This particular one was constructed for the purpose of automatically extracting water bodies from Landsat 8 imagery. Mousing over the model will show the description provided by the author. Then simply drag the model onto the canvas. Looking closer, you'll notice the model is comprised of different operators, ranging from simple mathematical functions like add and subtract, to more complex ones like one that converts raster data into feature data. The purple operators are input ports for variables which are later exposed to the analyst, so the model can run on new data with different parameters. The author of the model has complete control over how much the end user can modify the model. This flexibility helps ensure consistent results when needed, but also provides the necessary options for the analyst to be successful. Now let's see how simple it is to build your own model. Start by giving the model a name. In this example, we're going to take a point cloud, or LAS file, and create a shaded relief image with the option for the end user to set a few variables. Shaded relief images are often easier to interpret, and changing the sun azimuth and elevation highlights different aspects of the topography. Note that the ability to adjust the sun angle and azimuth of an existing elevation model is already available as a dynamic service in MapX. We can use the search option to locate the operators you'll need for your model, then drag them onto the canvas. As I mentioned previously, the port input operators are used to variabilize the inputs. In this case, we'll create 5 user-defined inputs: the input LAS file, the sun azimuth, the sun elevation, the units, and the name of the output result. Now we connect the ports in a logical flow. You'll notice I left the ambient light port unconnected. This port will still need a value, but as the author, I am choosing to predefine this input and not allow the user to change it. You'll also want to label the input ports so the user knows what values to input. In addition, you should provide a verbose description of what the service does. Now we can save and validate the model. The validation step ensures I have a logical flow, and if everything checks out, we're ready to test it. A test app is generated. On the left, you'll see the input panel with the 5 inputs that we defined previously. We select the LAS file, the elevation and azimuth, the units, and the output file, and then click Execute. The map window will show the results. With a little training, anyone can build a simple model, but other more complex models may require some foundational knowledge and more advanced training. For this reason, we provide several options, from full service, where our experts build models to meet your specifications, to assisted service, where our staff works with your users, to self-service, where your trained experts build your own models. Once you're happy with the result, you can export the model as a service. As a service, various deployment options are available. We can host these services on the cloud and automate the execution based on a set of rules. For example, a new image comes in. Based on rules set up against the metadata, we can execute pre-processing services on the image. This machine-to-machine automation can dramatically reduce the time between raw data and decisions. And of course, on the cloud, we can take advantage of the virtually limitless compute power. Another option is to add it to MapX as a geoprocessing service. We are currently working on a tighter integration between Spatial Workshop and MapX, so the model you just created can automatically be added as a service with the geoprocessing panel, just as we saw in the test application. Here we will see the raster expurgation service, which is used to black out sensitive locations in imagery. In conclusion, the Spatial Workshop will provide the tools you need to reduce or eliminate the manual, repetitive tasks of the tradecraft, freeing up time for the analyst to do what humans are good at. Building models does not require any special programming skills, just some basic training and an understanding of the domain. Finally, the concept of build once and run many will create consistent outputs, reduce rework, and improve overall efficiency.